Hello everyone, I'm Janice from Hober. Today we are going to have a solar power water pump system training class. Hober is a national high-tech enterprise of solar pumping inverter founded in 2009. Integrates in R&D production, sales and service, and we have more than 100 countries customers and serve a lot of clients all over the world. This is our team, and our team engineer Alan Boo is a software engineer and solar pump inverter programming. Pumping system training. What you will learn about the solar-powered water pump system: composition, installation, design, and troubleshooting analysis. Part 1: Solar-powered water pump system composition. The water pump system is a type of water pump system that provides by solar power. The system includes solar panel, AC pump, DC pump, and solar pump inverter and controller accessories, combiner box, cables, like this. Solar panels generate the DC power. So the important parameters is the solar panels IVMP and the VOC open circuit and the maximum power voltage. Solar pump inverter function: convert DC electricity produced by the solar panels into AC electricity and drive the AC pump. Solar pump controller driver is a device to regulate and control the operation of a DC brushless water pump. Is for DC pump motor. DC motor have 3 phase 24, 36, 48, 72, 96, 110, 22 VDC. AC pump have the 221 phase, single phase 50 or 60 Hz, 3 phase 380 volts, and the DC pump have some power from 200 to 2.2 kilowatts. The AC pump in the power range is very big, and the DC pump is high efficient, but the power is small. Part 2: Design solar power water pump system. First, you need to know the flow rate and height required to calculate the water model and size power, and then you choose the inverter model and size, and then you confirm the solar panel configuration, solar panel connection, and then another design based on the pump. For example, requirements: the submersible pump 6 km power and the vertical height 60 meters, horizontal distance 100 meters. For example, this example. So firstly, your customer want to know, I want a pump. So first to know the flow rate and the height. So the horizontal distance 100 meters equal to vertical height 1.13 meters, and this is the flow. 6 hours per day. This average the working hours per year. Per day, the 1 year have 4 seasons, so the average working hours per day is 6 hours in different countries. So we have selected the 6 cubic meters power, and because we have calculated the height is 63.3 meters and 6 kilometers per hour. So we choose or look at the pump catalog. 6. This 9 is the kilometers per hour. 1, 2, 3, 4, 5, 6, 7. So 6 is here, and then we have the 63.3. So we can choose the 83 is meets the requirements. And then we go back to the beginning. So the pump power is 2.2. So the 2.2 kilowatts pump meets the requirement. From the small power, from 1 horsepower to to 3 horsepower. We would normally choose the single phase 220 volts because it can save solar panels. So we choose the inverter 2.2 kilowatts. This HSPH is the manufacturer's product code, and 2200. This is the 2.2 kilowatts, and H is 3 phase 380 volts, and L is 220 volts, and the B is built in both. So this is the solar panel parameters. The important parameters is the power and the VMP, VOC. The power is this 405 watts, and the VOC 37 volts, VMP 31 volts. So firstly, we do the roughly calculation is solar panels pumps power multiply 1.5 solar panel watts. So you calculate total watts 3.3 kilowatts and divide 1 panel watts, and then you can get the roughly the quantity. Solar panels quantity is 8 pieces. So we have the solar panels, the minimum working voltage VMP 300 divides the solar panels VMP, you get 9. So minimum is 9, not 8. 8 cannot meet the MPPT voltage. So 8 is not working. 6 is working. 6 is voltage is this 188. It's not. It's less than inverter's minimum power supply voltage. The inverter will not start. Use 7 is working, but not in the max efficiency because the voltage is not more than 300 volts. We have, for another example, 400 kilowatts pump, existing pump, current used by generator. So how to use? You can choose the 5.5 kilowatts inverter. Inverter power is a little greater than pump's power. Then you can roughly to calculate the solar panel. Pump's power multiply 1.5 equal to 6 kilowatts. 6 kilowatts and divide the solar panels watts, and then you can get roughly quantity is 14. So 500 VMP, this is the inverter's VMP, divides the solar panel VMP, you can get 15, 6, near to 16. So 14 is not okay, you need to use 16 because it need to meet the inverter's minimum MPPT voltage so that the inverter can get high efficient. 16. So we have another requirement, 26 kilometers per hour, and the vertical height is 120. So horizontal distance is 200 meters, and then 24 hours working, continuous working. 100 horizontal distance equal to 6.6. So you can get the total height is 166, and then flow is 26. So we're going to 26 and 160.6. This is the water flow here. In the another attention is the check the pumps the capacity. You just choose the tool is not looking for the middle of this water, 18, 24, 28, 30, 32. Choose this, then you can 28, and then 133, and go back to here. In front is 15 kilowatts. So 15 kilowatts, the pump can meet the requirement. So we can design. We choose the 18.5 kilowatts, the inverter greater than pump's power. So solar panels Pump's power multiply 1.5 divided to the solar panel watts. The roughly quantity is 55 panels. So we use the continuous the constant hybrid input. So we need to use 18 units per piece, because this voltage divides to solar panel VMP, MPPT VMP hybrid is MP and divides to 31 voltage. You need to use one string is 18, and 18 divides to, you need three strings. You need 3 strings, 18 pieces in series, and then total quantity is 54. Not use 55, use 54. So let's can get hybrid automatic switching. Part 3, solar water pump system installation. You first install brackets and then install solar panels and PV combiner box. PV combiner box is very important in the solar pump system. So must install a PV combiner box to get the panel and the water pump inverters protection. And the actually is for inverter, water pump, and wiring. This is the roof. Also, you have the in the field. You have the ground mounting system. Ground mounting. The solar panel installation, you must pay more attention on the cables wiring, installation tapes to not check whether the solar panel are broken or not. You need and each string must be same quantity and the same panels in one system. Each string same quantity and each string not max the voltage is suitable for the inverter. Each string must be same, and the solar panels must be good quality. And also, first to measure the voltage for each string, the voltage must be not a 5-volt difference, must be same voltage. Don't use the different solar panel parameters for one system. One system, the solar panel specifications must be same. Each string must be same quantity solar panels. This is the PV combiner 2-in-1. This is designed by Hober, and this is the flows for the solar panel. You connect here, and this is the DC output to connect the inverter, and this is the DC breaker and the DC surge protector. This is the AC breaker and the AC surge protector. And how to power the inverters and the combiner box. All the positive together, all the negative together, and peel all the cables and join together. Use the tips to rub it. This is how to wire the cables. And this is how to measure the system ohm. This is how to measure the pump's insulation measurements. This to check the pump is good insulation or not. This is how to connect the pipe. Solar pump inverter wiring. Before wiring, you need to measure the voltage. And forbid to add any breaker between pump and the inverter. And the UVW is separate. U is the UVW. Do not connect the pump ground wire to the inverter. Pump ground wire is connected to ground. The more attention, please look at this note. Troubleshooting. If have inverter have any problem, please connect inverter and connect pump and turn on inverter, press down K several times to see the solar input, AC output data, how to change, and record the video and send to us. And what output is small, check the suction, with the surface pump, check the suction height, whether it have air or not, and check the pump whether it is reversed, check the solar panel whether installed is good, no any object to block the solar panels, and check the solar panel configuration is good or not, check the solar panel, the insulation angle is correct or not, check the weather is good or not. This is check the suction pipe have water or not, check. So the surface pump need to set the PID. More details, please look at the user manual. Water pump is small, so maybe it's running reverse, so you can exchange two wells to solve the problem. 3-phase change the well, and the single phase must according to the user manual to do the wiring connection. IGBT OA means the AC output over currents. So you need a single phase pump. You need to check the wiring whether it's correct. And for the 3-phase, you need to disconnect the pump and then check the pump load is working or not. If the inverter no connect pump is working, it means the pump motor, pump well have problem. Overload, check the pump whether the current efficient the data whether it's correct or not. Before we pack the goods, all the programming is correct. Please do not change the current coefficients. It will be a problem with your inverters. Also check the pump's power is smaller. The pump's power must be smaller than inverter's power. If the pump's power is bigger than inverter's power, it will shows overload too. Solar overvoltage. Please check the solar panel voltage. For the surface pump, need to set the PID. The PID setting must check the user manual. And the solar panels, the voltage design must according to the parameters to check. And do not design the max the voltage for each string of solar panels, because in the winter some countries the solar panels voltage will be increased. IGBT over current, check the fans whether it's working, and also if put the inverter into a box, check the cabinet box whether it's ventilated, and do not block the top of inverter, because the air is from the bottom inverter to top. This AC out PGSC, that means the AC output short to ground. So you can check the pump's insulation, use the measure to measure the resistance of the 3-phase to ground respectively. Solar input voltage setting. You can set this for setting. This setting, if you set 25 Hz in 20 seconds, 5 minutes restart. If no connect to the pump, if no connect to the AC power, it means the no power limited protection. If the Hertz, the inverter, the running Hertz is too low, the inverter will stop and shows the PV low power. If connect to the pump, connect to AC power, so it will automatically switch into AC. So that's the AC-DC hybrid input. This is for the tank installation. More details you can look at user manual. and this is the dry run to set how to set. Later we will look at the user manual. Forbid to add the breaker between pump. No breaker between inverter and the pump. No breaker, no breaker. And this is serial IDs here, and then this is coefficient is on the label. This is sticker of the inverter on the side, on the right side of inverter, and this is the display board, the capacitor board, the motherboard, and this is socket for solar solar input, AC input, AC output. This is the keyboard for the LCD display, and this is for cable for the control board to the main board, and this is control board, and this is current sensor. Thank you.